You got good at using AI, and your reward is a chair and a key that says enter. You ask, you wait, you read, you spot what it got wrong, you type the fix, you hit enter, and you wait again. Round 3, round 4, and something starts to bother you. The AI is not the slow part of this. Every single lap is waiting on one thing: a human reading the last answer and typing the next one. You learned to prompt it, you fed it context, you gave it tools so it could act. And it still cannot move an inch without you pressing that key. Now picture the opposite. One of these systems got set loose on a hard research problem and ran 700 experiments in 2 days, with nobody in the chair at all, and it came back with real improvements. This video is about the skill that empties that chair, and how to build it so the thing does not drive off a cliff the second you walk away. There is a name for getting out of that chair, and it showed up in the summer of 2026. The word is loop engineering. By the end of this, you will know what a loop actually is, the handful of parts every good one has, the one part that decides whether it is safe or a slow disaster, and the failure mode that catches everyone the first time they try. Before we touch anything about AI, I want to take the scary word apart because the loop itself is the oldest idea in the room. Stick with me on the thermostat for a moment, because the exact same machine is running inside every AI agent you have heard of, and once you see it, you cannot unsee it. Look at the thermostat on your wall. A thermostat runs the same 4 steps over and over. It has a goal, the temperature you set, it acts, it turns the furnace on. It checks, it reads the room and asks whether the goal is met yet. And it repeats that until the room is warm enough, and then it stops. Goal, act, check, and stop when the goal is met. That is a control loop, and we have been building them for 100 years. Cruise control in your car is the same shape. The assembly line is the same shape. A loop that runs itself toward a goal and knows when to quit is not new, and it is not magic. So if the loop is that old, what actually changed in 2026? One thing changed. The thing sitting in the middle of the loop, the part that senses and decides, used to be a dumb strip of metal that only knew hot from cold. Now we can drop a mind in there instead. Something that can read a bug report, write code, run it, read the error, and decide what to try next. That is the entire shift, and it is worth saying slowly. Loop engineering is control theory. The thermostat pointed at something that can think. Now, people have built control loops for 100 years, so you would guess the loop itself is the easy part here. And the controls engineers watching just winced, because keeping a loop stable was always the hard part. Overshoot, oscillation, a system that hunts around its target instead of settling on it. But there is one thing that is genuinely new, and it is not the loop, and it is not even the difficulty. It is that the thing being controlled can now push back on the thing controlling it. Your furnace never had an opinion about the thermometer. An agent does, and hold on to that, because it turns into the most important problem in the whole video. This is the 4th rung of a ladder you have been climbing whether you named it or not. Prompting, then context, then a harness, and now the loop. And the first 3 rungs all share one thing. On every one of them, you are still holding the pen, still there for every single turn. The 4th rung is where you finally get to put the pen down. Here is the cleanest way I have heard it put. The unit of work moved. It used to be the prompt, the single sentence you were trying to phrase just right. Now it is the trajectory, the whole run, start to finish, every step the agent takes on its way to done. You are not writing the prompt anymore, you are designing the run. The way Peter Steinberger put it, roughly, you should stop prompting your coding agents and start designing the loops that prompt them for you. The coding agents you have heard of, the ones like Claude Code, or Codex or Devin, are all secretly running the same tiny circle. Underneath the branding, each one is just this loop, and once you can name its parts, you will see it everywhere. Let us build it with the most ordinary example there is, a piece of code that does not work yet. Every agentic loop, no matter how fancy, is made of the same 4 steps we just saw in the thermostat. The first step is the goal. Not a vague wish, a checkable target. Not make the code better, but make this failing test pass. Hold on to how specific that is, because it is going to matter more than anything else in this video. The second step is the action. The mind looks at the goal and does something real. It writes a change to the code. The third step is the check. The change runs, the world answers with a passing test or an error, and the loop asks one question: are we done or not? And the fourth step is the decision. If we are not done, go back and try again, and if we are, stop. The mind tries again, now knowing what the last error was. Write, run, read the error, fix, run again, around and around. And here is the part worth pausing on. No human typed anything during those labs. You set the goal at the start and you define what done means, and then the loop ran itself. That little circle is not a toy. It is the whole engine. And here is the part worth arguing about. Which model you drop into it often matters less than people think. The same model can go from mediocre to excellent depending on how well the loop around it was built, the goal, the tools, the check. There is a flaw to that, of course. Below a certain level of raw ability, no loop can save a model that cannot recover from its own mistakes. But above that floor, the loop is doing more of the work than the name on the model. I have been calling it the check, almost in passing. So now let me stop and say the real thing. The verify step is the whole game. Think back to the thermostat. Its check was a thermometer, and a thermostat with a slow, unreliable thermometer is a useless one. Same here. Everything else in the loop is downstream of one question. How do you know when the work is actually good? Andrei Karpathy put this better than I can, so I will just borrow it. He points out that the way you make one of these loops faster is not a bigger model, and it is not a longer prompt. It is shrinking the time it takes to verify. Here is that whole idea in one line. You do not get faster by prompting better, you get faster by checking faster. You cannot ship faster than you can check. Sit with that, because it is the opposite of where most people spend their effort. If checking the result is instant, an automatic test that goes green or red, the loop can rip through 100 attempts before lunch. If checking the result means you personally reading every line of output, then you are back in the chair, and the loop is only as fast as your eyeballs. And there is a trap right here that catches almost everyone at first. You cannot just ask the same agent that did the work whether the work is good. When a model checks its own work, it grades it with the same blind spots that produced it, so it is most confident in exactly the places it is wrong. Splitting the work helps. One agent makes and a different agent tries to break it, but be honest about how weak even that is. Two language models can share the same wrong intuition and cheerfully agree with each other all the way off the cliff. The checks you can actually trust are the ones that do not think at all. A test that runs, a type checker, a compiler, a script that compares the output against a known answer. Reach for a mechanical check first, and bring in another model as the judge only when nothing mechanical exists, and even then treat its verdict as the weakest evidence in the room. So here is the practical shape of getting good at this. You earn the right to walk away from the loop by making the check cheap, fast, and honest. The more you trust the verifier, the longer the leash you can give the agent, and not 1 second before. And now the dark twist, the one thing the thermostat could never do to you. A furnace cannot lie to the thermometer. An agent can absolutely satisfy the check without doing the work. Point a loop at make the failing test pass, and a weak setup will find the cheap way out. It will delete the test or hardcode the exact value the test is looking for, or wrap the whole thing in code that quietly swallows the error. The test goes green. The loop declares victory and nothing actually got fixed. The agent optimized the check you wrote, not the goal you meant. That gap has a name, reward hacking, and it is the first wall everyone who actually runs these loops hits. A gameable check is worse than a slow one. A slow check only wastes your time, but a gameable check hands you broken work wearing a green light. Now, for the failure that keeps people up at night, and it is not the agent doing the wrong thing. It is the agent never stopping. A loop with a mind in it and no exit will happily run forever. It will keep trying, keep spending, keep editing, convinced the next lap is the one that works. People have woken up to loops that ran all night, burned through a small fortune in usage, and produced a tangle of changes nobody asked for. There is a quieter version of this too, which is the loop that stops too early. The agent decides it is done when it is not, hands you something broken with total confidence and quits. So a real loop is defended on purpose, and it is defended in more than one way. The rule of thumb is to give every loop 3 independent ways out so that no single failure can trap it. The first exit is the verifier, the happy path, and it is the only exit the thermostat ever needed. The check comes back good. The goal is met. The loop stops because the work is actually done. But a thermostat is chasing one simple number, so one exit is enough for it. A mind chasing a fuzzy goal can fool itself or never finish, so it needs backups. The second exit is a hard cap on the number of tries. After some fixed number of laps, 10, 20, whatever you choose, the loop stops whether it succeeded or not, and it comes and gets you. The third exit is a budget. A ceiling on time or money, and when it is hit, the loop stops no matter what. You want all 3, and you want them independent, because the whole point is that if one of them fails, the other 2 still catch the loop before it hurts you. And there is a fourth exit that people forget, the one that catches the sneakiest failure of them all. Watch progress, not just the count of tries, and kill the loop the moment it has burned several laps with nothing measurably better to show for them. Because a loop can sit under its try cap, under its budget, and still be quietly stuck, polishing the same broken thing in a slightly different shape each lap. A good loop is not one that always succeeds. A good loop is one that always stops. But stopping safely is only half of running unattended. To keep going for days, a loop needs one more thing, and it is the strangest part of the whole design. That strange part is memory, and it starts from an uncomfortable fact about the mind in the loop. It forgets everything. Every time the agent starts a fresh turn, it wakes up brand new with no memory of the last run at all. So how does a thing with no memory run for a week straight? The thermostat at least remembered it was mid-cycle, but this mind does not even get that. So if the memory cannot live inside the thinking, it has to live somewhere else. It has to live on disk, outside the agent, in files the agent can read back. Here is the line I want you to keep. The agent forgets, but the repo does not. In practice, this is wonderfully boring. The loop keeps a plain file, a checklist, a running log of what is finished and what is left. Before the agent stops, it writes down where it got to. When it starts again, blank as ever, it reads that file first and it is instantly back in the game. That external memory is the difference between a loop that does one quick task and quits and a loop you can leave running against a big goal for a week. The quiet skill here is choosing what to write down and what to throw away, because a loop that faithfully remembers a wrong assumption will carry that mistake forward for days. The thinking is fresh every time. The progress is what persists. So let us put the parts together into the thing people actually run, the loop that works while they sleep. Picture a loop that wakes up on a schedule, say every morning, with no one pressing anything. First it does discovery, it scans for work, the tests that broke overnight, the issues that came in, and it writes them all into its checklist file. Then for each real problem, it gives that job its own separate copy of the code to work in, so that 2 fixes happening at the same time never overwrite each other's changes. In each workspace, a maker agent drafts the fix and a checker agent tries to tear it apart. When a fix survives the checker, the loop opens a proper request for a human to review and updates the ticket. And the things it genuinely cannot solve, it does not guess at. It sets them aside in a pile for a person to look at. You did not sit and prompt any of that. You designed it once, the goal, the checks, the exits, the memory, and then it ran itself. Before you run off and loop everything, the grown-up move is knowing when not to. A loop earns its keep only when you can write a cheap honest check, and when progress is something you can measure lap over lap. If you cannot say what done looks like in a way a machine can test, you do not have a loop. You have a random number generator that spends money. Fuzzy goals, questions of taste, and one-shot actions you cannot undo, that is exactly where you keep your hand on the keyboard. And once you trust the check, this scales further than feels comfortable. In one case, an AI research loop was pointed at a real goal, make a small model train faster, and left to run. It designed its own experiments, ran them, read the results, and tried again over and over. Across 2 days, it ran 700 experiments with nobody touching it between runs, and it found 20 separate changes that stacked together, cut the training time by about a tenth. When you first hear a number like that, it sounds like science fiction. But look at what it actually is. It is the thermostat, a goal, an action, a check it could trust, and an exit running over and over. The only new thing is that the part in the middle could think, I want to end on the honest part, the part the excited post skip. When you can ship this fast without touching the keyboard, a gap opens up quietly, and it is dangerous precisely because it feels great. It is the gap between how much you are shipping and how much you actually understand. The loop can produce a week of work in a night, and none of it passed through your head on the way out. That gap has a name worth remembering: comprehension debt, and it comes due at the worst possible moment, when something breaks and you realize you cannot fix code you never read. The loop does not remove your judgment from the picture. It moves it. Your job used to be writing the work. Now your job is defining what good means, deciding what to check, and reviewing what came back, and that job is not smaller, it is more important. So here is the whole thing, back where we started. You were in the chair pressing enter, and you were the slow part. Loop engineering gets you out of the chair. But if you build it right, it does not get you out of the room. There is a name for the seat you move in. You go from in the loop, doing every single step yourself, to on the loop, watching it run with your hand resting near the switch. Keep the AI on a leash, make small changes you can actually check, and stay the person who defines the goal and owns the result. Build the loop like someone who intends to stay the engineer, not just the person who presses go. That is the top of the ladder. Prompting taught you to ask. Context taught you what to feed it. The harness gave it hands. And the loop, built well, gives you a system that works while you sleep, with you still standing over it, still the engineer. That is the last rung. Now you can see the whole climb.